In this problem, we have kind of a scissor-like mechanism where this bar here is connected to ground at point D, and this point bar here is connected to ground at point E, and they're connected together at point C. So this bar, if we move it down into position, it's like this, as you can see in the book. And then we're told that we either have a couple or a moment acting at point A or point B, so we're asked to solve it for both those cases to see how the loads change. And so we go through the same process, right position vectors. I use point D as my origin, and so point A, B, C, and E, with respect to that origin, we can get their position vectors. Now the couple is in the clockwise direction, so it's a negative sign, since it would be into the page, so in the minus Z direction. And we can do force balances, force and moment balances on different parts of the structure here. I used this one with only D and E, force D and E acting. That was, I took the total structure because force C cancels out as an internal load, so that doesn't, well, you could put it in here, but it would cancel out because it's equal and opposite. And then here I looked at, let's see, I looked at just this straight bar, a straight linkage up here. And so just we have C and D forces, and then I added A in here. So I added, what I did here is I basically said we have A and B, and then I just said one of them is 0. So I solved it for the general case when they're both acting. So when you look at the total structure, you have external moments acting. So you have to supplement the moment equation with those external moments. And on the total body, there's 2 of them. On the upper bar, there's just one. And so what you'll see here is that we get, we wind up with 6 equations here, and we're going to have 6 unknowns because we have 2 components of E, 2 components of D, and 2 components of C. So we have 6 equations and 6 unknowns, and it's a matter of doing the algebra then to solve them. And what I did is I solved them in the general case. And then we were actually only asked for force at D and E. So these are the forces at D that depend on what this what the M is. And in the first case, MA was minus 150 and MB was 0. In the second case, MA is 0, MB is minus 150. And so we can just plug in our values here and get our 2 answers. So in the first case, we have 750 newtons in the horizontal direction, and minus in the second case. If you notice, these 2 things, no matter if if one of these is 0, then if they're equal and one of them 0, we'll get the same answer because we have the same coefficients here. So we see we get the same answer for, and this one is just the negative of this one. So we get the same answer for the vertical loads at the constraints, but for the horizontal loads we get basically we get a half. In the second case, when we have a moment down here, we have much lower horizontal loads acting in the structure at the constraint points here and here. And we can see that by these coefficients here. So this load is much more dependent on MA than it is on MB.